Today, we are going to understand risk-neutral pricing in a very simple way. First, what is risk-neutral pricing? In real life, investors care about risk. If an investment is risky, they expect higher returns. But in risk-neutral pricing, we imagine a special world where investors do not care about risk at all. In this imaginary world, every investment grows only at the risk-free interest rate. Now remember, this is not how the real world works. It is just a mathematical tool that helps us price bonds and options correctly. Next, let's understand the difference between true probabilities and risk-neutral probabilities. True probabilities are the real chances of something happening. For example, a stock may have a 70% chance of going up and a 30% chance of going down. These reflect actual market expectations. But risk-neutral probabilities are different. They are not real probabilities. We adjust them in such a way that the expected return of the asset becomes equal to the risk-free rate. The difference between real-world probabilities and risk-neutral probabilities is called interest rate drift. In simple words, instead of using investor expectations, we force the model to grow at the interest rate. Now let's understand how we use this idea in a binomial tree. In a binomial tree, at each step, the value can either go up or go down. Suppose a bond is worth 100 today. After 1 year, it can become 110 if it goes up, or 95 if it goes down. The risk-free rate is 8%. We now find a special probability, called the risk-neutral probability, such that when we calculate the expected future value and discount it back at 8%, we get today's price of 100. This probability is not based on real belief. It is calculated so that the model matches the current market price. There are two main ways to build this model. The first method is to adjust the interest rates in the tree while keeping real probabilities. We change the rates until the model price matches the market price. This creates a risk-neutral interest rate tree. The second method is easier. We keep the interest rates fixed and instead adjust the probabilities. These adjusted probabilities are called risk-neutral probabilities. Then we calculate expected values and discount them back using the risk-free rate. An important result is that no matter which method we use, the final value of the derivative will be the same.